to anything that cut down the freaking money for gas.
What happens when those batteries die? 5 years, those batteries will die. I completely done.
Ooh, why is there
How much do they get?
wow, look at the starting point.
The Lisa Rush is 5 years of and less money for gas. And it only raises your electric bill like $5. I've seen a video.
Have you seen this hydrogen car?
Lauren, where did you start? Yeah. Which is? 3. Very good. So as we graph this, all right, so here's the 3 that we're starting at. Y-intercept. 3. Oh, down 2 over 5 as our slope. Down 2, right 5. Down 2, right 5 as our slope. You didn't have anything on there. Okay, so you didn't do a negative slope. One thing I have wanted to be talking about. Because you go down 2, right 5. Down, right. One thing I wanted to review is that anything that goes uphill from left to right is a positive slope. And anything that goes downhill from left to right is a negative slope. Y'all remember that? Alright, continue. I'm gonna put something up here for a minute. There you go. We're looking at dashing things.
Yeah, I know. It depends on the sun. It has a line on it. So what's today's challenge? Burger. Self-made burger. Orange juice. All right.
Yeah.
Do I record it this time or?
Alright, so because this inequality doesn't have the equal to sign underneath it, we're going to connect these points with a dashed line. Tony, you remember dashing lines? So connect those points with a dashed line. Is our first graph done? Aiden. You gotta shade it. Inequalities require shading. We actually color in here. And this reads y is greater than. So I go to the y-axis, I put my pencil on my y-intercept, and I shade up. And I fill in that whole side. Inequalities require coloring. Done. So you gotta color it in. I have to color it in some more. All right, begin the second one. Do the second one on the same graph. They should both be graphs on the same XY axis. Yeah, don't put it on a different one. It's all transfer.
Did you find my ID? Huh? I said, did you find it? I don't know. This isn't my ID. It's my ID for the inside. I saw my landing in the front office. I was there.
Okay, if you guys want to take a picture of this, you can. If this isn't something that you just kind of naturally know at this point, you can take a picture of it, review it in the next week or two before your exam.
I got it wrong.
Okay, so now I'm going to graph my second inequality. Where do I start the graph of y is less than or equal to? You know, Thomas? You know where to start it? How do I graph this? Dominic, how do I graph this? Yeah, you start at 0, 0. There isn't a number here, so there's an invisible 0. So we begin at 0. And then where do you go from there? So now we're in the origin. Up to over 1. What? Oh, okay. And this time, should I do a dashed or a solid line? We can do a solid line this time. And I'll put my pencil on my y-intercept and I'll shade down because this reads y is less than. And I shade like all of this over here on this side. Gosh, my shading is not that great. Hope your shading's better than mine. I'm gonna do this on the screen next time. Huh.
Miss, yes, the test next to his brother.
Who? Tony? Who cares? Will you be more comfortable like that? Your brother can see your whole life.
Imagine being
Oh, you guys like know each other. You guys have like a little connection. You guys have like siblings that are like very close. Am I right?
twins?
Yeah. So you like understand each other. No? You might understand. Oh, so you can't relate at all? Oh, he agrees with you. I know. Alright, I'm recording. Just stop talking. Alright.
Yeah.
Alright, you guys. So number 2, possibly more important than number 1. Name 3 solutions to the system. Are you saying 5 and 7 go together? Because I need points. Ordered pairs. Solutions are ordered pairs. Okay, shh. Let's see if 3 and 3 work. What do you think? You think 3 and 3 work? I can't wait to find out if 3 and 3 work. Over 3? Up 3. Yes, 3 and 3 is a solution because it's where both lines are shaded. Solutions are where the shading overlap.
Oh, this is all supposed to be on one graph.
Yes, I said that.
on that. 4 negative.
Well, I can't bring it. Oh, I was in 2 separate graphs.
Alright, so after 1, so 5 and 7, do you want to pair up? Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I'll take 5, 7 work.
About 4 negative 5.
What?
4 negative 5.
Let's try 4 negative 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. No, it has to be where they're both shaded.
Oh, both?
both say that.
Yeah.
I think
2-2, no.
3-2.
1-2-3, 1-2. On the dash line, no, it has to be on a solid line.
Oh.
Bella, can you find one way back there? You're the furthest person from this picture. And can you find an answer to the solution to the system?
6-2.
No.
I
You're
think I'm
looking
on
here where they're both shaded.
They're right there.
What about 4-4?
4, 1, 2, 3, 4. I'll take 4-4.
If Lester's taking out,
3-6. The one's the one different kids lessons, whatever. 3-6.
I thought it was like question 6.
when? Bullshit. I don't know either.
Dude, how is it? She wanted us to do all these pages? Nice, you wanted us to do all these pages? Oh, miss. Because on 6 was last night. What? Yo, no way.
Alright, very good. I see I have a couple of confident answers here. So here's the work for number 9.
Where would you get that? It was
So
mine.
n is negative
Oh, it's
12.
on the TV?
Hey, we got it right.
You want to switch?
Is n equals 40 over 3. Any questions on number 9? Negative 12, comma 40 over 3. You add 24 to both sides. I'll show it. Plus 24, plus 24. And then you have 3n equals 40. N equals 40 over 3. Number 10.
I was playing headbands. We were playing headbands.
Alright, I want to be able to add down in number 10, but I don't have opposites. Janelle, how did you create opposites here? I'm going to have to multiply this whole bottom by negative 1.
The next period is probably the best period for me. TV production is like one of the best periods. Because it's fun.
Alright, add down and finish this problem right now.
Me and
The
Jack.
pink part. Add down and finish the problem. The pink part.
This one feels different.
Yeah,
This one I really like. Granted, this one just feels different.
Really? Finished it?
This one feels
Tyler, you have a question?
Is this from the homework yesterday? Or
This is due right now.
That's what I'm saying.
Yeah.
I can't.
Yeah.
I can't get all the way up.
K equals 0 and J equals 2.
Oh, I got it right.
you are on joke.
Oh, I was doing that. Now it's allowed.
Here's the second question.
Oh, I didn't write it down.
Oh, that's it right there? Oh.
See, because mine's burn. That's why I had to moisturize them. You don't know what moisturizer is? Lotion. Yeah. So that they don't burn. Well, that's mine. Yeah, that's mine. Thank you. I got everything back. I'm just gonna keep this one. $5 Coca-Cola.
You are on some joke team. You are on some joke team.
Alright,
You bust your hair.
we are now gonna do some EOC questions.
Shave it off.
But did you guys write the assignment down for today? Alright.
Probably like.
So I'm gonna be
Feel bad
giving
for
you
you.
Tony, stop talking. I'm gonna be giving you points for these questions I'm doing right now on the board with you, and this assignment for today, which is R3 19 through 21. Same answers will go. May 9th through the 13th. They put out a final exam schedule, but they didn't put out the EOC schedule.
I didn't know we had an
I'm not. I've already asked her. I'm not trying to like.
You know what we're probably gonna do next week class? Yeah. You know what we're gonna do? The question thing.
You guys. So yesterday, in a couple of classes, we ended up just doing like silent book work because they just kind of similar to your energy here. You don't really want to be hearing me do problems, and you're gonna focus better on the book work. If that's the case, fine. We can also do Chromebooks, and you can look at these problems yourself. You guys want to grab a Chromebook and look at these problems yourself so you can go through them at your own pace? No, you can either do these problems on Chromebooks right now or these problems on this screen. Do you need to see it right in front of you? Okay. All right, guys. So this is the graph of y equals x. Y equals x. Gabe, in this equation, what is the slope? And y equals x, what is the slope? This equation, just looking at the equation. There's an invisible 1, and then there's an invisible 0. So it starts at 0 and it goes up 1 over 1. Starts at 0, up 1 over 1. Now these actually go by 2s, just so you can see that. So you're supposed to describe how each of these graphs is different from this basic one. So you're going to go to letter A, and you're going to say, so this one's called F. You're going to say how G is different than F. No, they're not trying to say that these equations match this graph. They're saying actually the opposite. They're saying that each one of these equations is different from this. How is it different? So in letter A, I would say g of x starts at 0, 3. Whereas, is that one word? F of x begins at the origin. How did I know that? How did I know? I don't have a picture of this. They're challenging you. Can you abstractly picture a line without being given the picture? Can you compare an equation to a graph that are different? That's the challenge here. Oh, we gotta lock that door. Let's try that in letter B. How is h of x different from f of x? Dominic,
0.
how's h different than f?
Oh, 0, -5.
That's a 0, -5.
Just don't tell him answers. Let him think about it.
What's
What's a different way? Let's word it different than I worded letter A.
Well, Well, first of all,
I could say the y-intercept's different. I like that. I could also say h of x will appear 5 units lower. Because h of x has the same slope, but it would start here. And so it would be parallel. You could say that they would be parallel because they have the same slope, but it's going to be 5 units lower. Letter C. How is letter C different?
negative. It's a negative.
Or it should go from left to right.
Well, now you want to take my answer, huh? Take my answer.
J of x will show a negative slope. While f of x is positive. Okay, if I was to picture j of x, it would start in the same place at 0, but it would go down to over 1. It would look like this. How is k of x different?
The slope is bigger.
I'm going to say k of x has a steeper slope. The slope is bigger. The slope is steeper. This slope would be up 3 over 1 instead. This line's going to go up higher more quickly. It's steeper slope. Has a steeper slope, and I'm just going to say begins or goes through 0, 8. I think you guys got it. Good job. Gosh, this one's difficult. Ooh, it's difficult. Cindy and Simone are working on separate biology experiments.
Why did you skip 17?
It was more fun. Stop making all your noises. In Cindy's experiment, she started with just 1 cell, and her cells double every minute. Simone started with 80 cells, so Simone started with a lot more cells in her experiment. And this is what her cells were doing. This is Simone's cells, and we don't have a table for Cindy. Yeah, so, I mean, I like what you said, Benjamin. We know a lot. They told us we could make our own table for Cindy if we wanted to. Minutes, cells. At 0, she had 1. At 1 minute, she had 2. At 2 minutes, she had 4. At 3 minutes, she had 8. And at 4 minutes, she had 16. It's doubling every time. They didn't provide a table to compare. Okay, so this is actually like new within the last few years. When I had to take a test like this, they just made me compare 2 tables, right? But here, they want you to compare words. They didn't give you an equation for Cindy. They didn't give you a table or a graph for Cindy. All they said is that her cells are doubling. They want you to compare words to a table. So they want you to compare 2 different representations. Quite a bit, they want you to do that. So we're making this since they didn't give us a comparable table. Do the number of cells in Simone's experiment increase at a constant percentage rate? What is the rate? And if not, how are they increasing? So focusing here on Simone, what's happening to these numbers? This one goes up 40.
Boy.
135. So is this a constant percentage rate? we would have to do what's 60 over 40, what's 90 over 60, and what's 135 over 90.
60 or
150.
1.5.
So it's just doubling
The second one's 1.5.
Mm-hmm.
What's the third one?
1.5.
Wow. These are called constant ratios. All right. So, in exponential functions, so doubling bacteria growth. Hopefully, you thought of exponential. There are no words here to tell you besides percentage, but this is the credit card type problem. They don't tell you that. So what we see is that it's 1.5 every time. So does it increase at a constant percentage rate? Yes, it does. The answer to 18A is yes. What is the percentage rate it's increasing at? No. 50%. Because this I could write this equation now. It's 80 is the initial amount. 1 plus 0.5 raised to time. And that's how we get 1.5 is it's 1 plus a 50% increase. So we want to say that this is increasing 50% each minute. Whereas Cindy's is doubling each minute, this is only going up by 50% each minute. So letter B, in which experiment are the number of cells increasing more rapidly? In Cindy's they are, because they're doubling. How much more rapidly is doubling than 50%?
50%
Yeah, 50% more. Cindy's would have a 1 plus 100% here at 2. 50% more. Cindy's experiment is increasing more rapidly because her cells are doubling. Pretty challenging question there. So much background you have to have going into it. Right, so the next one. The best thing you can take away from this one problem is doing constant ratios to find percent increase, and then knowing that you may be asked to compare words to a table. Like they might not give you all the information they want you to compare. All right, we're skipping to number 20. A new computer repair company offers house calls to their customers. They use this function, 45H plus 80, to calculate the repair bill. You guys, I'll give you some time to do A, B, and C on your own. Please do all the way through C. Try to answer C. A, B, and C. Go ahead, I want you to answer on your paper. Good, Jake. Put that away. Answer on your paper.
45 represents the hourly rate.
Who said my name?
What does 45 represent more? Yeah. Okay. Mm-hmm. Yeah. That's maybe about
I really
charge per hour. And what does the 80 represent? Benjamin? The initial fee. Doesn't matter how long they go, they're charging $80 just to show up.
What's a port cost?
Because
an extra repair bill.
Or a part cost. Or you could call it like an assessment, a diagnostic. Like sometimes you pay people just to come out and say, you know, what would you charge just to rewire internet in my whole house? And they'll be like, well, we don't know, but if you pay me $80, I'll come check it out, you know? And so, if f of h equals 215, what does the value of h mean in the context of the problem? Anybody have an answer for this? It's worded very weird. Thomas. 3.
You couldn't be any more wrong.
Yeah, let's put more words to it.
Something.
So you solved it. What does 3 represent? Okay. If f of h equals 15, then they worked for 3 hours. How'd you figure it out?
And then 135.
And then you divide?
Yeah.
Did you write it or did you just do that like in your calculator? Yeah. So f of h, you take the f of h out and you put 215 in and then you can solve it. Alright, good job.
You use photo math.
No, you use photo math.
I didn't use photo math.
That's it,
I don't even have photo math downloaded.
Oh, I never think you did.
I used it. Photo math is my favorite.
Alright, so you guys missed the assignment yesterday.
It wasn't our fault, miss. We're taking the EOC.
I know. Or you can just start your assignment right now on page R3, 19, 20, and 21. You have the rest of class to get it done. It's not. No, the Tuesday one. You guys are going to Tuesday. What day are you not going to be here? Who's not going to be here tomorrow? Raise your hand. Who's not going to be here next Monday? Raise your hand.